why the future of tangibility? Okay, and, by growing complexes, we have a lot of wear and tear. Okay, and it's going getting complex day by day. In the process, we are losing kind of human senses, the richness of human senses we developed for our lifetime. So our attempt to here is to change that painted bits to the tangible bits, embracing the human touch, tangibility senses uh, by in combining both the for today's agenda by combining tangible augmented reality and ambient displays. We have to embrace the future of tangibility. And this may be our regular scenarios as a developers or kind of computer techies. We stare at glowing screens almost all the time, or either it may be mobiles or it may be your laptop screens or desktop screens, where we never try to interact with those mediums, as we had a even if we had a very rich senses of human touch and feel. And with that, we have a lot of lessons learned from the tangible interfaces from last decade and a half, I think. One is we learn how to use the objects smartly, and how we can collaborate with the mediums of tangibility and touch interfaces, and we increasingly understand the cognitive effects day by day. And with that, we come across with the limitations. It's really difficult to change object properties, and another display capabilities, and we stayed apart from the displays and separation between the object and displays. Okay, on all three things, we had lost in growing more and more with the computing world, and to cover up that gap, we are proposing this medium, tangible augmented reality. Uh, for the future, it's going to be the new approach of design, or mixing virtual and physical worlds together and embracing enhanced display possibilities, and merging the tasks and display spaces with public and private views. And how it's going to work is right looking when we imagine that when there is a virtual world where there is a real world, and now the current scenario is we are two different paths. We never merge them together, and to bring near to the reality, and with these tangible interfaces, and making with in leveraging the augmented reality with the tangibility, we are bringing to the next level of the exploration for the future generations. And this is a sample of the video where recently, in pandemic days, and how we can leverage these tangible interfaces uh, as with human controlled robots. And just there's a guy in Japan who's developed this particular model, how it's exactly how you are working, and how your hand senses and how your tangibility is making. Exactly, he's transferring that to the robot, and what you physically is not there, but virtually he is in the robot, and as a human, it's exactly reacting to his senses. Uh, this is what we are aiming to achieve in this process of uh, today's subject. Uh, And along with this, I'm passing on to the Sanjeev for talk about some augmented surfaces and its capabilities, how it's going to be built.
Thank you, Suresh. So let me explain the basic principles of augmented surfaces. So we create virtual objects. Those are projected on the surfaces. It could be as simple as the walls or on the floor, or on the white sand that we use frequently, or on the tabletop. And these objects are controlled by physical objects such as joysticks, AR, VR headsets, or some kind of remote devices. And most important principle is it should allow collaboration between multiple users to enable parallel activity. And I'm going to explain the four major stages involved in the development of tangible user interfaces. So the first stage would be creating a meaningful prototype that we all do with all our projects to demonstrate the purpose. Second step is adoption of existing interaction techniques like using sensors or cameras and so on. And third step is to develop new interface metaphors, which is very specific for our purpose. For example, if we are building an interface for supermarket, it could be rotate hand gesture to view the products in 3 dimensions. And the fourth step is developing a formal model, which is basically the output of first 3 steps with the research and analysis for the future predictions. So let me put tangible user interfaces in a broader context. So as we all know, we build experiences around human natural behaviors. So basically, we are leveraging 4 natural themes of our interaction with the world. So naive physics is a common sense knowledge people have about the real world, like we sense any danger or any harm. For example, if any object is falling on us, we react accordingly. Second natural awareness people have is their skills to control and coordinate their bodies. So as I said, if some object is falling on us, we decide whether to move away and avoid the object, or whether to put our hand to block it. Also, we have skills to manipulating and navigating our environment. And the last one is we have skills to interact with each other, and we have the ability to work together. So we can leverage these natural human interaction skills when we develop tangible user interfaces. So let me play a video which gives you an idea how natural gestures can be used to create mixed reality.
We've been exploring how to control everyday objects in mixed reality. Our case study is music control. Quick gestures work with simple tasks like advanced tracks. For more complex interactions like editing the playlist, the interface pulls open. Songs are added by picking them up and setting them down in the playlist. Voice input speeds up tasks like search. Show me songs by the Beatles.
So as you can see with the basic gestures, how we can control the mixed reality objects. So Suresh is going to explain it further. Thank you.
So those most natural that the video we have seen right now was the prototype. It's an imaginary prototype, but what's next one was the video. This is really near to the. It's a very few seconds video, but this is the original prototype is in development by one of the researchers, and that means we are very near to the reality, and we can get that natural senses and go to the next level of scenes. With that, we're landing on the functional scenes versus cognitive scenes. Okay, now why we have to do this? So, there is we have a lot of input devices and something like when you uh, when you are using your interactions with these spaces, always we are dependent on some kind of input devices we interpret with the display system, and it's becoming like more of learning. Every time there is a new device comes, okay, there is kind of new kind of learning need to be happen. and that learning is forcing users to learn different techniques. And other way, the contrast of the air interfaces overlay with the real world graphics, and that will make us seamlessly interact with the displays. And with that, advantages of we'll briefly touch about the advantages. One, few of them are it's a two-handed way 3D interaction models, and it doesn't require some kind of extra gear or input devices. And the one with AR tangibility will be consistent and very simple and effective. And it can be a really ad hoc actually. Okay, it can be one of the major interesting property of the tangible reality. AR is ad hoc and highly reconfigurable, and it can be editable, and they many ways it can be customizable always. And one more biggest advantage was a physical form factor, which supports in any kind of surfaces. And with that, we just defining is a ideal tangible AR interfaces is where where user can make seamlessly interact with interfaces without any friction. There, we can clearly removing the functional and cognitive seams. That will give the user to the next level of experience. And so next level was the tangible AR interfaces, and there is two kind of tangible interfaces currently available on the wide range of the market. One is a space multiplex interfaces, which is broadly AR group, something with music performance interface, okay, which is very popular right now as well. And shared spaces where a lot of gaming kind of stuff is coming up, collaborative gaming stuff is in very near in future. And third one is Tiles, a virtual prototyping application, where you can interact with multiple objects at a time and create your customized layout. And third one is a time multiplex interfaces, which is called again as WOMR, one of the stream. And this is a multiple objects can come together and collaborate, make them to work with each other, and make a great interactive tangible interfaces. And next, we have this shared space multiplex examples. Where in the left side you can see there is two guys are playing the game. Okay, they're keeping their hands in the card. Two cards is representing. One is alien, another one is UFO. And when these two guys bring the cards together, what will happen, right? Okay, when alien jumps into the UFO and started its journey to the next level of gaming, and where you are not only virtually, you are physically also involved with that kind of collaboration that makes more interesting to for the players as well as experiences. And going after that is a WOMR. Okay, so where is a multi-thread multiplex the interactions in our and assembling a lot of objects together and putting them together and make them to work whatever the way you want. Actually, you can customize it based on your user requirements, where you will get that kind of satisfaction. Okay, the customization is every human looking for. Okay, and to fit for their exact requirements. That's where this OMR is going to help us a lot. Okay, and I'm going to play one example of it and how this OMR is going to change our lives in future, and how easily we can assemble our spaces. This is one of the examples where the researchers are attempting to change the way we are working right now. How the interfaces can be rapidly changeable based on our user requirements. there's a lot of cards placed on that board. Each card will represent one object, and you can start playing with those objects, kind of aligning them and rotating them and customizing them. Or if you don't want, as a user, can remove it, and it can be various options are there. And currently, AR, VR, mixed realities, and we have large a number of systems are coming up. But what this tangibility is giving more advantage is the customization based on the spaces availability. And apart from that, you can see that that user is trying to move the objects from left to right, or removing some of the objects, and making it in a look more of personalization. And apart from that, there is a modes also you can see virtually, and but it's almost near to the reality world, where you can see the morning, midnight, morning, midday, and the sunset, night. Okay, and all these different modes, how that particular display system is going to be look like. You can imagine before you're going to get into the objects, you're finalizing the objects. That's one of the great exposures. This tangible augmented reality is helping us to develop the systems, future systems, and with that, we have a lot of limitation coming with that, because as a humans, we have n number of senses we developed for the lifetime actually, and we have every time we will be like our senses, our touch and feel, tangibilities will change, and we have inbuilt senses or metaphors we already developed for the years together. So what we are suggesting here was, okay, let's leverage those developed senses rather than depending upon the input devices, and making let's take into the next level of interface, or we can the way we are interacting with the displays. And with that, there is we have a number of again, okay, we have a number of gestures and senses we carry along with us, but we have to see what is going to be like fit for that particular environment, or the particular computing some computing software developments we are doing, and what kind of senses is going to fix. Okay, we have to be really careful over this, not to make too much clutter, and take the advantage of representation forms. Okay, and just we have to limit our thinking rather than going too broad, and we have to balance between the physical and digital representation as well. Here, that's the biggest challenges in this particular TUIs. And this is the conclusions. What we're going to do is, right, okay, definitely the AR is going to be the future of tangible AR is going to be the future of interfaces, and there's going to be a new design system is going to come, and which is based on the principles we got it from the tangibility for the many years we developed, and there's a lot of research is available on this particular topic, and more and more hand interactions and two-handed gestures is going to be take us into the more comfortable and commandable, controllable places. With that, next level was the ambient displays. What we're going to be included. The ambient displays. This is we have the older kind of surfaces we can explore, where all kind of information is available, and this is a kind of graphical representations, and just the user can allow to explore. Okay, this is kind of just you can go and explore the particular parts, or you can go and explore particular how it's assembled, or learning capacities. We can leverage that one. But here is we talk again. We as users, our interaction with these kind of interfaces is limited. It's a one way to be specific. Okay, and it's kind of just you can touch and zoom into the particular area and explore those ideations and content you can grasp from there. But with with that, what we are going to do was there is a many people know that there is a display new methodology with sandbox theory. Okay, and this based on the uh, levels of the imagery. Okay, automatically the change will we are making the changes along with lighting effects and making tangible bits into the real world bits. This mixing with this kind of technology, we can achieve much bigger results on the tangible augmented reality. And this is a form we are going to expect for the future. And Based on these learnings, we how our world is going to be, and based on our research, what we did, we came up with a small prototype, imaginary prototype, which is how we can change our world in next level. Especially as a designers, we know this process from the uh, business requirements gathered, and then those bits is passed to the experienced designer. There's a gap again. Okay, and once the experienced designers transfer into the UI designers, there's a gap. Okay, and again, it's a flow is like a kind of very typical way we work. Okay, with the different kind of Jiras or different kind of softwares, and by the end, okay, from the end to end, the journey was not seamless. Okay, it's kind of friction every stage. We are feeling like some kind of friction, and for that, leveraging this tile-based prototyping approach, we are trying to come up with a kind of with kind of a prototype, which is just it's a graphical representation I'm doing, and I'm not getting this right kind of opportunity to build the next level. I'm going for it in future. There is a business requirement guy in a single place where we have all the people come together and explore the each and every interaction, how these things are getting developed. And seamlessly you can go to the business requirement, and I can see what's the requirement. I can go to the experience design, I can see what's happening over there, and if there is any kind of misalignments, we can call it out. And UI design is what is it's seamless. Okay, and when you're changing the tabs, what you saw on the tiles based Umar approach, we can leverage that functionality over here, and put do these bits into that tangibility and explore our next generation progress. And this is tangibility. Okay, and if something like I have a requirement 118, maybe the user gave requirement number one number, and I need what is the requirement number was the solution must reduce the need for paper records. So once I kind of search for that or click on top of that requirement, automatically I will come to know what's happening in other domains and other what is the kind of journey we're going through. Okay, this is a particular to the requirement, and it's published. It will give the status. And next, we'll go to the experienced designer, and he's already done with his work and he's published. And then I can go to the seamlessly. I can interact with these journey, and finally this I just developed till visual design, and it's got approved, and I'm passing on to the dev. And it has to be happen seamlessly with a tile-based prototyping. And this is the first level, and maybe in the second level, maybe just with a voice search, what we learn from the guy who's asking for the Beatles, and where mixed reality is happening. And I'm going to speak, okay, and just I need a requirement 118, and then I can interact with those developed pieces into the one, or in the one place. I can refer what is my requirements, and I can see different spaces, what I'm what as a designer, what's happening in the other domains, and is it everything is in a fix, or we can go and give the feedback, and visual design we can leverage. This is kind of imaginary prototype with the hand gestures, so we can move the all these tiles around and explore inside, and rather than going to the different paths, we're trying to bring it into the one place with with the help of ambient displays and tangible augmented realities. And with this, I need to thank you for Kumar. Okay, to put us into the next level, where we are just where we are feeling like we have to stop in some place, but he's asked to go for next level to bring some kind of prototypings into the real world, and how we're going to be like develop those pieces into the tangible painted pieces into the tangible pieces. Definitely, I'm looking for that next level of prototyping on this particular piece. With that, I'm closing. Thank you for your time.
Thank you for having us, listening to our thoughts on the future technology. Thank you.